J-HAT 塾
Please hit subscribe.
This problem appears at the 2018 Physics Questionnaire of the qualifying examinations for applicants for Japanese government or MEXT scholarships for undergraduate students. The answer key and the original questions are linked in the description. Problem 4 of 1. A screen is placed at a large distance L from the plate, where two slits, S1 and S2, are notched. These slits are separated by a distance d, as shown in this figure. A monochromatic light from a single slit, S sub O, with a wavelength of lambda, passes through the slits S1 and S2. Bright and dark interference patterns appear on the screen. Find the distance from the screen center O to the third dark line. Let us recall the following for this problem. Here we have the distances from the center. So if we have an interference experiment, such as in the problem, if we have two slits and the distance of the screen is much larger than the distance separating the slits, then we know that the dark and the bright fringes, bands, will alternate on the screen. Right at the center of the screen, we will have a bright band, and that's constructive interference for the bright bands. And the next bright band will be x distance from that center. And here we have lambda to be the wavelength of the light, L the distance of the screen, D the separation between the slits, and here n is an integer. When n equals 0, that is where we have the center of the screen. So right at the center of the screen, we have constructive interference or bright bands, and next to it will be a dark band, which is indicative of destructive interference. And next to the dark band is another bright band, which will be given by this. So x here is the distance distance to the center. And here we can also find the distance from the center of the next dark band. That's given by this. Here again, n is an integer, and when n is 0, that is the dark band closest to the center. So if we plug in 0 here, we get 1/2 lambda times this ratio. And you can think of it like we are shifting 1/2 lambda, 1/2 of a wavelength away from the center. And that makes sense because if you recall, when we translate a wave 1/2 of a wavelength, that is the same as flipping the wave. And so if you add that to the original wave, you add the original wave to the flipped wave, you get destructive interference. So that's one way of remembering these two formulas. So when we know this, the problem becomes very straightforward. We are looking for the destructive interference band, which is the dark band. So we're using this formula, and we are looking for the third band. The distance of it from the center is what we're looking for, and that is precisely given by this formula. X is the distance from the center, and because this is the third band, we are looking for n equals 2. Remember that n equals 0 is the first band. So n equals 2 is, we just replace the n here with 2, and we just do the arithmetic, we get this.
If you learned something new today, please help my channel by clicking the subscribe button and the bell for the notifications. See ya!